students, welcome to the class. So as we are discussing the current electricity chapter, in the last class we came to know that whenever the electric current is passing in the conductor, it is producing the magnetic field in the surrounding area. So from this we got the conclusion that the electric current is the source of the magnetic field. So from the last class we came to know that whenever the current is passing in the conductor, it is producing the magnetic field in the surrounding area. So the magnetic field had been created because of the current in the wire. So nothing but electric current is the first and the main source of the magnetic field. Now as we know, the magnetic field we will denote by the letter B, and its unit is nothing but Tesla. So Tesla is the unit of the magnetic field. So when current is flowing in the upward direction, it is producing the magnetic field whose direction will be in the anti-clockwise direction. At the same time, when current is flowing in the downward direction in the wire, it is also producing the magnetic field and its direction will be clockwise. So from this we got the direction of the magnetic field from the Maxwell right hand thumb rule. So by using the Maxwell right hand thumb rule, we got only the direction. But in the today's class, we are going to find the magnitude of the magnetic field. So that is nothing but the B. We are going to find the B value, and its unit is nothing but the Tesla. Now, as because of some current, let it be I. So when I current is flowing in the wire, it is producing the magnetic field of 1 Tesla. Let it be 1 Tesla. Now I want to increase this magnetic field. So how much I want to increase? I want to increase to the 2 Tesla. If I want to increase the magnitude of the magnetic field to the 2 Tesla, then how much current I should pass in the circuit? That is my first question. So what is the first question? If you want to increase the magnetic field, it may be in any amount. So if you want to increase the magnetic field, then how much current we should pass in the circuit? This is the first question. And the second question, as we know, the magnetic field is created in all the surrounding area. So whether the magnetic field at all these points will remain the same or it will be different. So if it is different, then on which quantity this magnetic field depends. So it depends on which quantity. So that is what the second question. First question, if you want to increase the magnetic field, then how much current we should pass in the circuit. And the next question is whether whatever the magnetic field is created in the surrounding area, whether its magnitude will be same at all the point. Is it same at all the point or different? If it is different, of course it will be different. So if it is different, on which quantity it will depend. So to get the answer for all those questions, they made a one law that is called as what? Biot-Savart's law. That is nothing but the Biot-Savart law. There is two scientists. So one scientist name is Jean Biot, and next scientist is nothing but the Felix Savart. So these are the two scientists, the Jean Biot and the Felix Savart. So they combinedly made this law. That's why we are giving the name what it is, Biot-Savart law. Then let's see the law what it says. So according to the Biot-Savart law, first we are taking one conductor which is having length. So let the length of the conductor will be, I will denote by L. One long wire, conducting wire is there. Its length is nothing but what? L we are taking. Then certain current we are passing in the conductor. The amount of current I am passing in the conductor is nothing but I will denote. So that I is the current which is passing in the conductor. So as it is a conductor, when current is flowing, of course it is producing the magnetic field in the surrounding area. Now we want to find the magnitude of that magnetic field, because already we had calculated the direction of the magnetic field. Now to find that magnetic field, one point I will choose. So let it be the point is nothing but here. I am taking the point P, and I want to find what is the magnitude of the magnetic field at this point. Coming to the point, when current is magnetic field. In all the cases, we chosen one point P. Here we are finding the magnitude of the magnetic field. If it is the case, the primary thing is what? The magnetic field depends upon what? That will be the question. Suppose 1 ampere of current I am passing. It is producing certain magnetic field at this point. If I increase the current to 2 ampere, 3 ampere like that. So if the strength of the current goes on increases in the wire, then the magnetic field created will be same or it will be different at the point P. Of course it will be what? Different because of the changing of the strength of the current. How the strength of the current goes on increases, the strength of the magnetic field created at a certain point is also what? Goes on increases. This is a common sense. How current will increase, like that the strength of the magnetic field also what? Goes on increases. So for this we concluded that the first primary thing the magnetic field depends is the what? Current. So how current increases, the magnetic field also what? Goes on increases. This is the first thing. The next thing, current is nothing but what? The flow of electrons, the flow of charges. So as the charge want to flow, it want the length there. If the length is there, then only it can flow. So if you didn't take the length, then it will not pass. That's why the length plays an important role for the what? Motion of the charges. So as the charge want to flow, in conductor electron is flowing. So as electron want to flow, it want what? Certain length. Next, the thing is what? Length is playing the important role here. So to get that length, as it is a long wire, infinitely long wire we are taking, one small length I will consider. So here, from here to here, I am considering the length. Suppose this is the length and its length is nothing but dl I will take. For long wire, the total length is L. So as we are consider a small element, so small length it contains. That's why how much it is length? dl we are taking. As say, suppose this is the length and it produces some certain magnetic field here. Now, if I double the length, then the magnetic field created here will be double or not? Yeah, of course it will be what? Double. That's why from this again second thing we concluded, that is nothing but it depends upon the what? The length of the element, isn't it? So that depends upon the length. That is what the second point. And the third point, if you go, what is the specification of this point? That is the P point. So what is the specification? So it is there at a certain distance from the what? dl. Now I will join the point to the what? The current element what we had chosen. This is the element we had chosen and which is there at a certain distance. So the distance of this one I will take it as r. R is the what? Distance vector of this point P we are taking. And when we are talking about the specification, of course then it is there at a certain distance. At the same time it is there at a certain angle, isn't it? And that angle I will denote by theta. Theta is the angle between this current element and the line joining the point P. The line joining the point current element to the what? Point P. So from this another thing we are telling. So as I said, suppose dB is the magnetic field at a point P, because if whole length if you consider, total magnetic field we will get at a point P. But now presently we are calculating the magnetic field only due to a small element dl. That's why small magnetic field will be created. So I had chosen dB instead of what? B. So suppose this is the magnetic field at a point P. So it depends upon certain quantities, and that quantities are nothing but, as we discussed first, it depends upon the what? Current. Is it the first thing? So completely it depends upon what? Current. And second thing, it depends upon the what? The length, the path in which it is moving. So the length of the current element, that is nothing but dl. So it depends upon the what? dl. And when we talk about the third thing, on which quantity it depends. So as I said earlier, it is having certain specification. The point is having certain specification. When it is here, suppose the point is here. So that time it is nearer to the DL, the length element. As it is moving like this, the angle goes on increases, isn't it? So as the angle goes on increases, what is happening? The magnetic field goes on decreases and decreases. Is it the thing? It will goes on decreases and decreases. Means when it is here, it is maximum magnetic field producing, and when it is changing its position, angle goes on changes, and when it will come here, so that time the magnetic field goes on decreases and decreases, and it will be zero at this point. So from this we can tell the magnetic field here is completely depending upon the what? Angle. When it is here, the angle becomes what? Theta is equal to 0 degree. And when it is moving like this, when it is here, the angle becomes what? 90 degrees, isn't it? And when angle goes on changes, and if the point will come here, the angle becomes what? Theta is equal to 0 degree. So how the angle goes on increases, the magnetic field created by this one also what? Goes on increases and increases. So from this we will get the conclusion that the magnetic field depends upon the angle, and how the angle increases, the magnetic field increases, isn't it? Means can we say it depends upon the sign of the angle? Sin theta it is. That's why we came to know that the magnetic field depends upon the what? Sign of the angle which is joining the current element and the point P. This is what the thing. And the last point on which it depends is the, suppose this point, if it is here, the distance is lesser, means the magnetic field strength will be more. So how the changing its position? So if the distance goes on increases, weaker and weaker magnetic field we will get at the point P. Means it is depends upon the what? Distance, but not directly. It is what? Inversely. Because when the point here, maximum magnetic field is there, and how point distance goes on increases, the magnetic field quantity goes on decreases and decreases, and at one point it will be 0. So from this we got it is inversely proportional to the what? Distance. It is inversely proportional to the distance, but not only the distance, it is inversely proportional to the square of the distance. Inverse square law is applying here. Is it the inverse square law? So from this we concluded that the magnetic field depends upon the what? Distance. So nothing but it is inversely proportional to the what? Square of the distance, not directly, because as the distance increases, the magnetic field goes on decreases, increasing, decreasing we are getting. That's why it is what? Inversely proportional to square of the distance. Means inverse square law is applying here. So these are the 4 quantities on which what the magnetic field we got at the point P, it depends. So from this directly we will come to know Biot-Savart law says that the magnetic field at any point depends upon 4 quantities. It depends upon how much quantities? 4 quantities it depends. The first quantity, and this is the most important quantity, is nothing but what? The current, the strength of the current. As the strength of the current increases, magnetic field also increases. Or if it decreases, the magnetic field also decreases. So it depends upon the strength of the current. And the second thing is it depends upon the length of the current element, isn't it? So how the length goes on increases. Small length if you take, small magnetic field will produce. So higher length of the conductor we will take, maximum magnetic field will be producing. That's why it is depending upon the what? The length of the current element. And the third thing, it depends upon the what? Angle, which is connected between the current element and the point P. So this is the third thing. As sin theta value, if you know, sin 0 is equal to 0 we will get, and sin 90 degree is equal to 1 we are getting. When the point is here, the angle will be how much? Theta is equal to 90 degree. That's why it is maximum. And how when the point will come to here, the angle becomes what? 0 degree. So that time sin 0 is equal to 0. So how the angle increases, the magnetic field also what goes on increases and increases. That's why it depends upon the what sin theta. And the last point, it depends upon the what distance of that point, which is inversely proportional to the square of the distance. So this is what on what factors it depends. Now we should combine all these points. We are combining all these points to get the what dB value. Now can we write dB proportional to, so what is directly proportional to I dl and sin theta. So we will write here I dl and the sin theta whole divided by, as it is inversely proportional to 1 by r square, divided by what we will get r square we are getting. So dB proportional to I dl sin theta divided by what r square we are having. Now as it is a proportionality constant, we should replace with the equality. So when we are replacing this one to equal something constant quantity will be the multiplication factor here. For this something will be multiplied, and when we will change the proportionality here, something proportionality constant will come. That is nothing but mu naught by 4 pi. The proportionality constant is how much? Mu naught divided by 4 pi into r dl sin theta divided by r square. This is what the thing. Where something we got, as 4 pi is a numerical value, it is a constant quantity, 4 into 3.142. And when we are talking about the mu naught, as I said, of course it depends upon the 4 quantity, but another quantity is there, on that also the magnetic field depends. That is nothing but mu naught. Mu naught is called as, mu naught is nothing but, it is permeability of air. It is nothing but what? The permeability of air medium. Means what? There is some characteristic of space is there. Air is nothing but a space, we will say. So something characteristic of this space is there, which is allowing this magnetic field whether it should enter to the space or not. If it is entering, how much magnetic field should enter to the space. So this space having certain characteristics. So that characteristic will decide the magnetic field will should spread in this space or not, and that characteristic is called as what? Permeability, isn't it? And mu is actually the permeability. Mu means it is for any medium. If you take other medium, it is permeability of the medium. But as we are talking about the air space here, so air is there, that's why it becomes what? Mu naught. So mu naught is nothing but what? Permeability of the air. This is what the thing about the mu naught. And now I should find the value of the mu naught. So what will be the value? Actually the value of the mu naught is 4 pi into 10 raised to minus 7. So what is the value of the mu naught? 4 pi into 10 raised to minus 7. And what will be the unit of this? So we will go to this equation. As the equation is dB is equal to mu naught by 4 pi I dl sin theta divided by r square. We want to find the mu naught equation. So mu naught is equal to what we will get? dB into 4 pi into r square divided by I dl sin theta, isn't it? So what are the units here? dB, as I said, Tesla, into 4 pi numerical value, so no any unit, and it is r square, means can we say meter square, divided by I will be ampere, dl length, again we will measure by meter, into angle it is, so let it be. Now meter get cancelled, so what we will get? T Tesla into meter divided by ampere, means per ampere we are getting. That's why what will be the mu naught value? Mu naught is equal to 4 pi into 10 raised to minus 7 Tesla meter per ampere. So this is what the value of the mu naught. Okay, or you can write it as what? Mu naught by 4 pi is equal to 10 raised to minus 7 Tesla meter per ampere. Like that also you can write. So anything you can put. put in the equation and substituting all those things, you are getting the magnetic field, the point where you have chosen current, length of that element, angle and the distance, at how much distance it is there. Mu naught divided by 4 pi value is 10 raised to minus 7. So when we are substituting all these values now, you are getting the what? Magnitude of the magnetic field, isn't it? Now, if you want to write this equation with the direction, only it is giving the magnitude. So if you want to write the equation with the what? Direction, then it will come in what? Vector form, isn't it? So the vector form of the equation is, you should write like this. So this is the what? Vector form. If you show the arrow mark, means showing the what? Direction. It says it is showing the direction. dB is equal to mu naught by 4 pi. I is a scalar quantity. So we are not showing the what? Arrow mark here. Next, here whatever is there, I will make certain changes to write in a vector form. That is dl cross r divided by magnitude of r cube. It is the what? Shows the what? Vector form and it is showing the magnitude. This is what the difference. Okay. Now coming to the point, how it can be getting the in magnitude and the direction. As we know, A cross B is equal to AB sin theta. A cross B is nothing but what? AB sin theta. Here dl cross r is there. Means how to write this one? dl into r into sin theta. So change like that. So what we will get? Mu naught by 4 pi. I will be as it is. This becomes what? dl r sin theta, isn't it? Divided by this is what? R cube is there. Now 1r get cancelled. So if it get cancelled, what value we get? Mu naught by 4 pi into I dl sin theta divided by r square. Are you getting this point? Means nothing but the same point we got already, isn't it? So that's why this will give only the magnitude and this is giving the what? Vector form. Means with the direction we are writing the equation. So this is about the magnetic field, on which factors it depends and what is the magnitude of the magnetic field and the direction also we are telling. So as already we know, when current is flowing in this direction, how will be the magnitude? It is in anti-clockwise, means normal to this point. It is normal to the point and that one we shown by the what? In the vector form, isn't it? So now from this we got the what? The magnetic field at a certain point from the what? Biot-Savart law. Biot-Savart law says that the magnetic field at any point depends upon the 4 quantities. One is the strength of the current, second one is the length of the current element, third one is the sign of the angle between the current element and the line joining the current element to the point P, and fourth one is inversely proportional to the square of the distance between the point to the current element. When we will join all these things, we will get the equation. To replace the proportional, we are having some proportionality constant mu naught by 4 pi, where mu naught is nothing but permeability of A. Means dP depends on this one also, because it is deciding whether the magnetic field should allow the space or not. That's why this is the characteristic of space, which allows the magnetic field to spread in all the area. And next one is 4 pi is a numerical quantity, and we got this one value, mu naught by 4 pi is equal to 10 raised to minus 7 Tesla meter per ampere, and in vector form we will write like this. So only show the arrow mark for the vectors. dB is vector, so we are showing. I is not a vector quantity, we are not showing the arrow mark. It is a scalar quantity. Again dl, r and the r cube we are having. So this is all about the what? Biot-Savart law. Next, we are moving another concept of the magnetic field in the what? Next class. I hope you understood all these things. Okay. Thank you guys.